All right, so in chapter 7, we're looking at trying to find estimators of proportions and means and variances or standard deviations. So when we're looking at a confidence interval, we're confident that the true proportion is in between these values. So our best guess is this p hat, right? So this is from a sample and plus or minus some margin of error. During elections times, we see this a lot. We'll say that someone has a 36% approval rating plus or minus 2%. So we'll see these proportions everywhere. So the p hat is our best guess. That's from a sample. And so if we're given some values here, a pretty wide range, if we wanted to find out what our p hat was, it's just halfway in between because we're adding and subtracting the same number. So if we just add these things up and then divide it by 2, that will give us our p hat. And then to find the margin of error, that e value, it's just how far do I have to go to get to that upper value for my interval, my confidence interval. So let's do 0.999, 0.999 minus 0.555. I could have done 0.555 minus 0.111. Either way, I get this 0.44. So that stands for my margin of error. Next, let's look at number 5. On 5, we're given some data. So construct a 90% confidence interval to estimate to estimate of the percentage of yellow peas. Wording sounds funny there. But a genetic experiment with peas resulted in one sample of offspring that consisted of 442 green peas and 162 yellow peas. So we're looking at the percentage of yellow peas. So what I'm going to do is to construct this confidence interval, I'm going to take us to StatCrunch. And our numbers were 442 and 162. So I'm dealing with proportions. So I'm going to do a proportion stat. And I'm dealing with one sample. And I'm dealing with a summary. I don't have all the data in here, but just a summary of the data. And so I'm doing a confidence interval, right? So we put in the 90%, and we're going to use this standard walled as the one. There's different algorithms for confidence intervals, but we're going to use this standard one. So number of successes. So let's go back and look at the problem again. So we had 162 yellow peas, and again we're looking at estimating, I'm getting a confidence interval for yellow peas. So we have 162 as our successes. And then the total number of observations isn't that other number 442. It should be the sum of those numbers, which would be 604, because that would be our total observations. And once we do that, all we do is compute. And it's going to find us our lower limit and upper limit. So if we're going to 3 decimal places, I get a 0.239 and a 0.298. And a 0.298. So that's our 90% confidence interval. We are 90% confident that the true proportion of yellow peas is going to be somewhere in between this 23.9% and 29.8%. We're 90% confident it's somewhere in between here. It's our best guess. Given that the percentage of offspring yellow peas is not 25%, do the results contradict expectations? Well, we said that it's somewhere in between here. It includes 25, right? So could it be equal to it? I'm going to put includes 0.5, so the true percentage could easily be 25. So, no, the confidence interval includes 0.25, so the true percentage could equal 25%. One more from this section is number 11. This one is doing sample size. And they have a nice calculation to figure out sample size. But if I know that I want my estimate to be within 0.02%, so that's my margin of error, and I have a confidence interval of 90. I'll show you how to do that with StatCrunch. So we're still doing proportions, right? But we're going to do a power sample size. So now we're doing the power sample size. Don't worry about this hypothesis test power. So again, we're not worrying about this hypothesis test power. We want to look at the confidence interval width because we're dealing with confidence intervals. They've given us most of this information. They said previous estimate was 0.42. We want to be within 0.02 and a 90% confidence. So there's my 90% confidence. My target proportion is at 0.42. And again, that's something from a previous sample. And our width isn't going to be 0.02. The width is plus or minus the margin of error. So we'd actually have to double this and say 0.04. So there's our confidence interval. There's a previous sample that was taken. We found this proportion. And then there's a width. It's a double our E value because that's the width of the confidence interval, 0.04. And so we get a value of 1648. For the next one, we don't have any prior estimates. And how you work that is if you don't know any prior estimates, you just guess 50%. Because that's just our best guess. If we have no idea, we're going to say 50%. It also allows us for our most number of people that we would need to sample. Again, we're still at this 0.04, which is double that margin of error. So we have 1691. And so doing these problems, if we're using StatCrunch, can be pretty easy.